My name is Kyle Travis and welcome to our video. So for today, we will learn about limits. The aim for this is for you to understand more about limits. In mathematics, a limit is a value that a function or sequence approaches some value. A limit are essential to calculus and in mathematical analysis in general, and are used to define continuity, derivative, and integral. And there are three ways how to solve a limit. First is the popular value, second is the limit theorem, and third is the direct substitution. But we must focus on direct substitution. So, what is direct substitution? Direct substitution is just what the name implies, and you directly substitute a given value into a limit. When we use direct substitution, we use direct substitution when you have a simple function with addition, subtraction, multiplication, division, powers, and groups. We'll show you some examples of how to solve direct substitution and how to get a factor and how to touch that.
I will give you some example on how to solve direct substitution and limit. First, limit of x cubed as x approaches to 2. Just substitute 2 to x. 2 cubed. 2 cubed is equals to 8. And that's for first example. Now, I will teach you on how to get a factor. Example. Limit of 1x squared plus 3x minus 10 over x minus 2 as x approaches 2. Now, we will find two numbers that if you multiply it, the answer is 10. Then if you add it, the answer is 3. Now, we will find numbers that if you multiply it, the answer is 10. 5 and 2 is the two numbers that if you multiply, the answer is 10. It's either negative 5 or positive 2. Positive 5 and negative 2. But we will use the positive 5 and negative 2 for this video. Because, no, we will use the positive 5 and negative 2 because if you will add it, the answer is 3. So the factor that we will use is 5 x plus 5 times x minus 2 over, just copy the denominator which is x minus 2. Cancel, cancel. Equals so x plus 5 is only the number or the variables that left. X plus 5. No. Now, we can simply use the direct substitution. Just substitute d2 to x. 2 plus 5 is equals to 7. So 7 is the answer for this given example. For the next example, limit of x squared minus x minus 6 over x minus 3 as x approaches to. Be reminded that we can only use direct substitution if and only if the function is in its simplest form. So the given example is not in its simplest form. For us to have the answer, we will get the factors of negative 6. The factors of negative 6 are negative 3 and positive 2. X minus 3, x plus 2, divided by x minus 3. These two here are the factors of negative 6. And x minus 3 here is from x minus 3 in the denominator. So just copy it. Just cancel. So the only left is x plus 2. Now, we can direct use or just use the direct substitution. Just substitute 3 to x. 3 plus 2 is equals to 5. Now, we get the what we call it the answer for this given example. Now, I will teach you on how to solve rationalizationism. First, limit radical sign x plus 2 over x minus 4 as x approaches to 4. Be reminded that we can rationalize a function if it has radical sign and in a fraction form. So, from the given example, x plus 2 over x minus 4, then the x plus 2 has radical sign. So, from this example, we will be using rationalization. First, just copy the radical sign x, then transpose the positive 2. So this will be negative 2 over, just copy the radical sign x minus 2. Because we'll be multiplying the radical x by itself so that the radical sign will remove like this. X multiply radical sign x is equals x. So the answer will be positive 2 minus negative times negative 2. So the answer will be x minus 4 over, just copy the x minus 4 because x minus 4 doesn't have a radical sign. So we will just copying it. X minus 4, then the radical sign x minus 2. Here. There. Then, cancel. Be reminded that there are always 1 in the numerator because that's the rule. 1 over radical sign x minus 2. So this is the simplest form. So now we can direct substitute the 4 to the x. 1 over radical sign 4 minus 2. So the answer will be 1 over 0. This example is in the determinate. So, the limit or the example does not exist, or the limit itself does not exist. D and E. Thank you for watching the video, hoping that you understand our lesson. Thank you.